So what we're going to do is number 17. The cross-section of a water trough is an equilateral triangle with the horizontal top edge. If the trough is 5 meters long and 25 centimeters deep and water is flowing in at a rate of 0.25 meters cubed per minute. And the question is, how fast is the water level rising when the water is 10 centimeters deep at the deepest point? We're going to use a method called DREDS. D-R-E-D-S. D is for diagram, rate, equation, derivative, substitute, specific, info.
Okay, so I drew the diagram for the question earlier. This is a cross-section of a water trough which looks like a triangular prism. The length of the trough is 5 meters and the height is 0.25 meters. We changed 25 centimeter given in the question into 0.25 meter for convenience. We are looking for the rate of increase in water with respect to time. The height equals to 0.1 meter.
Okay, so the first thing we can do here is trying to relate volume to height. So volume of this triangular type of section is going to be equal to one half times base times height times the length. So that's the volume of water in a trough right now. So I'm just going to write that as an equation. So volume equals 1/2 times base times height times length. So that's basically the volume of water in a trough right now. But you have two problems because you have two unknowns, base and height. So if you're driving this straight, then you would end up with dB dt and dH dt. So what the heck are we going to do here? Well, I'm going to attempt to show you what our options are. So here is our diagram looks like if you look straight into it. So we know that this whole height of the trough is 0.25 meters and this is 60 degrees because this is an equilateral triangle, and because we cut this in half, that's 90 angle and that becomes 30 degrees. So 90 minus 60 is 30. So now we have an angle and the opposite side and an angle and the unknown side, so we can find this length by using the sine law. So now we're going to solve sine 60 degrees over 0.25 equals sine 30 degrees over x. And if we just cross multiply, that becomes 0.25 sine 30 degrees over sine 60 degrees. And 0.25 is 1/4. And from special triangle, we know that sine 30 equals 1/2. And sine 60 equals √3/2. And if you simplify all that, it becomes 1/4 times √3. So the x, so half of the length of the triangle is 1/4 √3. So we need the whole length. So we multiply this by 2. And the 2's and 4's cancel out. So the whole length of the triangle, sorry, the base of the triangle is 1/2 √3. So now we know that the whole length is equal to 1/2 √3. And we have the height of the trough, which is 0.25 meters. So now we can use similar triangle rule to find B and H. So we're going to make height and base the same ratio. So height, the smaller height to the big one, equals B over 1/2 √3. So the smaller base to the whole length of the triangle. So they're in proportional due to the similar triangle law. So if we cross multiply these two, it becomes 1 over 2 root 3 times h and 0.25 b. Now we want to isolate b, because if we look at the equation, it's v equals 1 over 2 b times h times l. So we want to eliminate as many variables as possible. So we're going to choose to eliminate b and make that in terms of h. So if we divide both sides by 0.25, it becomes 2 over root 3h. So now we have b equals 2 over root 3 times h, so we can sub back into the equation. So 1 over 2 times 2 to the root 3 h times h times l. Now we know L is given, it's 5 meters, so let's sub that in. 3 times h, height, times 5. Now these 2's can cancel out, and h times h equals h squared, so if you simplify this, it becomes 5 over root 3 times h squared.
So from here, now we have to derive this function, which is dv over dt equals 5 over root 3 times 2h times derivative of this, which is dh over dt. From here, we have to use implicit differentiation. So dv over dt is given from the question, which is 0.25 equals 5 over root 3 times 2. And the h is 0.1 meters from the question, and dh over dt. So this is also equal to 5 over root 3 times 1 over 5 times dh over dt. Then these 5 cancel out, and now we have 0.25 times 1 over root 3 times dh over dt. Now we multiply both sides by root 3. Then it is root 3 times 1 over 4 equal to dh over dt, which is root 3 over 4. Therefore, the rate is root 3 over 4 meters per minute. Therefore, the rate of height of water rising at 0.1 meter is root 3 over 4 meters per minute.